Bismillahirrahmanirrahim. I am Professor Jamil and you are watching my YouTube channel. Today we are going to solve a problem on Cauchy-Riemann equations, and let's get straight into the problem. This problem explains how can you find derivatives in different directions. Let's read the problem first. Here is the statement of the problem. Show that given the Cauchy-Riemann equations, the derivative f prime z, prime means df by dz, in the denominator you have dz, has the same value for dz equal this a dx plus ib dy, with neither a nor b 0. A and b are not equal to 0, as it has for dz equal dx. Mean when the Cauchy-Riemann conditions are satisfied, then you need to prove that function fz has derivatives for dz equal to dx and dz equal to a dx plus ib dy same. To prove this, let's get into the solution. And before starting the solution, you should recognize that value of dz has been given in terms of the Cartesian coordinate system. It's x and y. It is for this reason that you will use your complex function fz in Cartesian form. Let's write. Let's start on the other board. Solution in Cartesian coordinates f of z is equal to u of x and y. This is a real function of two variables x and y, plus iota v. V is also a function of two real variables x and y. Now, and where z in the Cartesian coordinate systems is written as x plus iota y. This is the general formula for the complex variable. And you need to find f prime z. F prime z means df of z divided by dz. This is something which you need to evaluate, and you can name it as equation number 1. Now, in the first case, your dz is equal to dx. From here, dz in general is equal to dx plus iota dy. But this dz is equal to dx. Therefore, dx equal dx plus I dy, and this means dy is equal to 0. So, when you will evaluate this derivative for this value of dx, your dy will be 0, and dy 0 means y is a constant. This means y is a constant, and your variable is only x. So when y is constant and y constant and x, this is real part of z. Let me explain in the form of a picture. Origin, this dz, remember complex number is a vector, so dz is also a vector. This vector may point in any direction. Let this points, but for this case dz is equal to dx, so it points in this direction. This is your dz equal dx. So when you use dz equal to dx, it means you are finding derivative of the complex function along x-axis. Okay, and when you are finding derivative along x-axis, then x is the variable, y will stay constant. So this dy equal to 0 means y is constant, and y is constant means you are taking derivative along the x direction. So let's use equation 1. So equation 1 gives, what it gives? F prime equal d of fz, and fz is equal to this much, u plus I v. Remember, u is a function of x and y. You do not need to write x and y again and again. Similarly, v is also a function of x and y, and you do not need to write it again and again. And it divided by dx. Instead of dz, you have substituted dx. Now, you may think of this derivative as a ratio of two numbers. One is differential of u plus iv divided by the other one is dx. And you may write dx as this, and this differential of this means differential of u plus iota into differential of v. Now you need to take differential of u, and u is a function of two variables x and y. So its differential will be partial u by x into dx partial u by y into dy plus iota into differential of v, and v is again a function of x and y. So differential will be v over x into dx plus partial v over y into dy, and close the bracket. But your dy is 0, and when you substitute here dy 0, then this term will become 0. Similarly, this term will become 0, and you will get what you get. Let's write over here. This implies f prime z is equal to 1 over dx into partial u by x into dx plus this is 0. So and plus 0 means nothing, so you get plus I next, and this piece partial v by x into dx, and plus 0 you do not need to write, and you mention that dy is equal to 0. Look, this dx can be taken out, and in front of the bracket you have dx by dx out, and you have partial u by x plus iota partial v by x, and this dx will cancel, and your f prime z is partial u by x plus I partial v by x. You may name it as equation number 2. Now, according to the statement, you have found f prime for dz equal to dx here. Now you need to evaluate f prime z again, but for this value. Let's use then equation number 1 again, and use dz as a dx and plus iota b dy. So make a little heading for dz equal a into dx plus iota b into dy. Here is a heading. The equation 1 gives, look here, f prime z is equal to d of fz, and fz is again u plus iv divided by dz, and dz is this, a into dx plus iota b into dy. Now What is a into dx and iota b into dx? This is dz. And let's find it or fix it in our mind in the form of a picture. This is real part of the variable, complex variable z, and this y-axis is the imaginary part of complex variable z. And here you have origin. Now, dz has this x component and this much y component. So dz may point in this direction, in which this is your dz now. And this dz, you can write in full, this dz is equal to abx plus iota b dy. And if you look carefully, then this red line, this is a vector a into dx, and this blue one is a vector b dy. So dz has two components, a into dx plus b into dy. And in this picture, a is positive and b is also positive. And if a is negative, then the red vector will be shifted on the left, and similarly dz vector will be shifted on the left in this way, right? And if b is also negative and a is negative, then this a negative means red vector is in this direction, and this blue vector will be the downward side, and the black vector will come down in this way. So a and b, when change sign, then dz will change. So this is the kind of arbitrary direction, black direction, in which we are now finding the derivative. So this f prime is now a derivative of the complex function u plus iv. U plus iv means complex function fz in arbitrary direction. Let's check how can we evaluate it. And okay, I will explain it in due course. Let's move on to the other board. Here, now you need to know this equation. Now let me make it clear to you. Yes, this equation, this differential of u plus iv will mean this d of u plus iota dv, and denominator will be same. So this is f prime z equal du plus iota into dv, and in the denominator you have a into dx plus iota b into dy. Now take the differential, and 1 over this a into dx plus iota b into dy, and differential of u is a function of x and y, and differential will be partial u by x into dx, but this dx is the real part of your dz, and that is not dx, it is a dx. So you will write a into dx plus partial u by y into dy, but dy is b dy, mean coefficient of this. So it is b into dy plus iota into dv, and dv is partial v over x into dx, but your dx is not simply dx, it is a dx. So it is a into dx plus partial v over y into dy, and dy is not simply dy, it is b into dy. Look at this, it is b into dy. b into dy and bracket closed. You can refer because dz is dx plus iota dy, but this time you have dz equal to a into dx plus iota b into dy, and this is dx plus iota dy. So your dx is this a dx, and similarly this dy is this one b into dy. That is why partial u by x into dx, and that dx is not dx, this is in our case a into dx. Similarly dy, and in our case dy is b dy, and similarly here. Now you can simplify it. This is the important step which you need to know. And if you are feeling some disturbance, please pause the video and go back a few minutes and then re-listen and re-watch this step again. So now you have derivative of u with respect to y and derivative of v with respect to y. Whereas in the earlier case, you have calculated derivative and it contains only derivatives with respect to x variable. Mean u is differentiated with respect to x, v is differentiated with respect to x. But here you have derivative of u with respect to y, and v is also being differentiated with respect to y. So these derivatives with respect to y need to be converted into derivatives with respect to x, and such transformation of the derivatives is provided by the Cauchy-Riemann conditions, and they are given in the statement that Cauchy-Riemann conditions are satisfied. Look, show that given the Cauchy-Riemann conditions, mean Cauchy-Riemann conditions are given to you, so you can use them. So let's try. By using Cauchy-Riemann equations, and these are the equations: u by x equal partial v over y, and partial u over y is equal to minus partial v over x. We get, let's see what we get. F prime z is equal to 1 over a into dx plus iota b into dy into partial u by x will be kept the same, no change, but partial u by y is to be converted into derivative not with respect to y but with respect to x. So let's check. Partial u over y is present where? Here you have u over y, and this is equal to this. So this u over y will be replaced with minus v over x, mean minus partial v over x. And the other piece b into dy is the same. Right. Plus iota into, this is derivative with respect to x and will be kept as such, plus v over y, partial v over y. Let's check where is it. Here is partial v over y, and this is equal to partial u by x. So this partial v over y will be replaced with partial u over x. So it is partial u by x into b dy, and the bracket closed. Now you can expand 1 over a into dx plus iota b into dy into, this thing is partial u by x into a dx. This is minus, plus minus will make minus, partial v by x into b dy plus iota partial v by x into a dx plus iota partial u by x into b dy, and the bracket closed. Now look, you have some simplifying steps. This term and this term, they have a dx as common, and let us write it. A into dx plus iota b into dy, and here you have partial u by x plus iota partial v by x, and a into dx is common from these two factors. Now look at rest of the two. From these rest of the two, you are looking that v into dy is common from these two, and take it common, and you will be left with the plus term is being written first, iota partial u by x, this one, and then this one, minus partial v by x, and from these two terms the b into dy is common. Now partial u by x has coefficient 1. Here partial u by x has coefficient iota. So you can take this iota out of this bracket first, so that these two terms may look same. Here you are, 1 over a into dx plus iota b into dy into, this part is same, no change in it, plus when you take I out, then here partial u over x will have coefficient 1, and minus here you will have 1 over I and partial v by x and b dy, bracket closed. Now you know 1 over I is minus I, and that minus will make this minus plus, so you have plus I, and let's write it here. Okay, I write here. Okay, here f prime z, make a line, f prime z is 1 over a into dx plus iota b into dy, and bracket starts. The first part will be written same, again no change in it, partial u over v plus iota partial v over, partial u over x plus iota partial v over x, and common a into dx plus iota, there was a iota or not? Yes, this iota, and this partial u by x, partial u by x, and next 1 over I is minus I, listen again, and that minus I due to this minus will become plus I, mean plus iota. So here you have plus iota and partial v over x, and outside of this bracket you have b into dy, so you have b into dy, and bracket closed. Now this piece partial u by x and this one, it may be taken common, and I take it a into dx plus iota b into dy, and when this is taken out of the bracket on right hand side, for example, then you will have a into dx plus this iota and this b dy, and partial u by x plus iota partial v by x has been taken common from the square brackets. You may also write this common factor on the left, but I have written it on the right, no problem. Now look, these two, one in the square bracket and one in the downside, they are same and they will cancel from each other, whole piece, and you are left with partial u by x plus iota partial v by x, and this is f prime z. You may name it as equation number 3. Now look, from equation number 2, for dz equal to dx, your derivative is this, partial u by x plus iota partial v by x. And from equation number 3, the derivative from equation number 3 mean for this dz equal to this thing, your derivative is again partial u by x plus iota partial v by x, mean the derivatives are same. So from equations 2 and 3, we see that f prime z for, you may develop your own symbol, this dz for dz equal dx is equal to f prime z for dz equal to a into dx plus iota b into dy. And this was your question, statement of the question, that f prime z has same value whether dz is equal to dx or dz is equal to this much. So this completes solution to your problem, and when you have completed solution to your problem, please always make a box on your result and write ANS, so that the examiner is, or the man who is looking your paper is convinced that you have found the final result. So here is the final solution, mean according to the statement. This is the statement, that f prime z has the same value whether dz is equal to this or dz is equal to this, and we have proved it. Thanks for watching. Keep watching, and please subscribe, share, and press the bell icon, so that my new solutions to the problems and the rest of the lectures comes to you in the first place. Thanks for watching.